And for the default, the ship structural mass, we've got the self-weight of the model, but we also have various tabs here where we can apply additional loads. And on the mass tab, and this is probably the most important one out of the various loads tabs, is, oh, and I guess as you turn things on and off in here, you'll see additional items being listed in the active loads description here. So, oh, maybe if I create that load, so you can see still water is in there. If we add an acceleration and modify it, oh, it's not letting me do that. Let's try corrosion. It's not letting me do that either. We'll look into that. At any rate, the on the mass tab, there's a number of different types of mass we can apply. Now, the first one is the volume groups. Now, these are our tank loads. In order to do that, we're going to need to define a lot of groups to represent each of the tanks in the hull. And we'll talk about groups a bit more, and we'll go through and define them on this hull a little later in this session. And as you've seen already, groups are extremely useful in Maestro. We use them for applying all of the properties. We use them for defining these loading groups. We use them for corrosion. They're extremely useful, and there's additional tools that we haven't looked at yet for manipulating those groups. We have the module masses, where we can basically just scale the mass of an entire module, and a good example of that might be with the OSV model, where, let me open that real quick. But the more accurately we can describe our mass distribution in the model, the better. And while we can have a smeared mass distribution, we can only model so much of the actual structure and have that self-weight applied. There's going to be pieces of structure that we don't model, brackets and other small items, maybe not all of the foundations and so forth, and certainly plenty of additional structure like furniture, piping, electrical, all of those other things that add mass to the hull but aren't considered structure. We need to account for that, and we do that with the additional mass distribution. Now, when Maestro applies that additional mass distribution, and we give it a curve along the length of the hull representing how we want it distributed, it will apply that to all of the individual nodes in the model, and it'll add pieces of weight throughout, distributing it, trying to match a desired VCG. If you tell it to, it'll try and match the VCG and the weight location along the length of the hull in each segment. Now, to match the VCG, if we start distributing that mass along all of these points, it doesn't have a lot of high vertical points over the aft portion of the hull, so it may start to push the mass up towards the deck and concentrate masses a little higher. Well, to prevent some of that, what we could do is grab just this superstructure module, or actually, since there are actually several, oh no, there's only one module here, just the superstructure module here, we could create a module group and assign a larger mass to it. If we know the total mass of the superstructure, we can assign it to the superstructure here, and that section of the model will be heavier. So the distribution of the weights in the rest of the hull can be a little more uniform throughout. It won't be trying to push them high to match the VCG because we didn't have enough weight modeled up in the superstructure. Point force, probably won't use that too often in just a standard ship analysis. There may be occasions where, if you want to load a crane or something where you have a need for a specific point force somewhere in the model. But the most common ones that we're going to be using are, I'm sorry, I should have marched down the rest of the mass tabs before moving on to that. So some of the other loads were, point force, pressure loads, and then the balance for basically doing a free float, which can either be on still water, a sine wave, or a torquedoidal wave. And if we are using a wave, you can also add Krylov effects if you want. But getting back to mass, we have the volume masses for our tanks, the module masses, if there's a specific region of the ship that you want to scale the weight. Section masses, now these are somewhat older, and if you want to read about any of these things, you can always go into the Maestro help, and under loading the model, defining loads in the mass tab, read about sections. And these were, I guess, and it even mentions in here, I think that this is for very early stage design, and it's just an estimation. It's almost a sort of an early version of what the mass distribution is doing, and the mass distribution is more accurate, which is on this last tab here, and that's the one that we'll typically use to distribute the additional masses throughout the rest of the hull. Nodal masses are very useful for modeling things like engines or specific pieces of heavy equipment. For things like engines, a mast, or generator, reduction gear, whatever. A lot of times we will create the nodes, assign a mass to that node, and then use R-splines or not R-splines, RBE elements to connect them to the footprint where they would land on the hull. If we modeled the foundation, we can connect them to the foundation. Otherwise, we can connect them to the deck. Another use there might be like the propellers. You may want to sort of model the struts and propellers as a weight, just a nodal mass, and connect them to the hull where the struts would attach. Plate groups are very useful if you want to define distributed loads for, say, an area of the deck where you'd contain cargo. Well, I guess, and those are based on plate groups. So in this drop list, you'd have to define a plate group before you can use this plate mass. The other thing about nodal masses and plate masses is that when you define them, and this applies to the module mass as well, when you define them, there is an associated weight that you define. So in the groups tab, when it's created and placed in the groups tree here, it'll have a mass associated with it. But when you implement it in a load case, such as like with the plate load, if that plate load represents an amount of cargo in a particular hold, you may not have the same amount of cargo for each individual load case. So you can, when you add that group, you can change the mass that it's going to use for this particular load case. And when you do that, it'll ask you, do you want to change it as the default on the group you created, or just leave it only applying to this load case? The bay masses are for large items, like if you were modeling a container vessel. These could be used for modeling the containers. This is, a lot of these things are items that I've never had a use for, or I've never actually used some of these items. They're available in Maestro if needed, but some of them, like this bay mass, is a fairly specific use case. And we'll be going over the more common ones that you're likely to use. For these other ones, you can always refer back to the help if you want additional descriptions of them. And certainly, if the need arose where you were going to use something like that, you could always contact us and ask us any questions that you had. But for those that are not used very frequently, we're not going to spend a lot of time looking into them. Now, the mass distribution is a very important one, and that one we will be using a good bit. So of these mass tabs, the ones that you'll most commonly use would be the volume groups for your tank loads, nodal masses for heavy items such as engines, props, and so forth, possibly plate groups if you have areas of the deck for cargo or equipment that you'll be using, and the mass distribution.